Thank you all for joining. So, as you see on the screen, this presentation will focus mostly on automotive, modern cars with a lot of gadgetry, with a lot of features, a lot of electronics is the challenge what we are seeing in the market today. So we are working with a lot of OEMs in India, abroad, and all around the world. ZEISS being a global company, and we have a lot of expertise in this topic around failure analysis in and for EV power electronic components. It will cover power electronics, but it will also cover a variety of different examples to give you an idea as to how we can use our one of our measurement solution for failure analysis. Moving on, one of the key things what we have realized in the market is that speed to market is the most important thing today. There was a time when one car used to be launched in 6 months, but today we find a plethora of launches, feature additions, new electronics getting embedded and coming up. So speed to market is the key in the field, whether it is for new product development, when you have a challenge to develop a lot of new products within a short time, or for field failure analysis. You have a failure, the part comes back to you, and you need a first information report. What has gone wrong? So this is the topic what we want to address in the next 45 minutes or so. So this will be the kind of agenda, short notes of ZEISS, what we are, electronics and automotive, and some case studies. My name is Manoj, and I head business development at ZEISS. ZEISS in India, ZEISS is a multi-dimensional, multi-divisional presence in India. We belong to industrial quality and research, the one in the left corner. This is our solution, and we work with almost all the automotive companies in India for the last about 50 years, and about 30 years we are directly present with all of you. Focusing more on our division, to which me and Suresh Babu represent, the most important information in this slide is that all the blue locations where you see, they are marked with pictures, and you will find a lot of equipments. They are our exhibition centers or demo centers or capability centers. You can walk in, and whatever solutions me and Suresh will talk today, most of them are available in these centers. So it is available in Gurgaon, Delhi, Hyderabad, Chennai. This is very important that whatever you see videos, you should be able to experience it. And that is possible with ZEISS, with our presence around the country. So make it a point to mark this slide and contact us later on. We are a 200 member team, approximately 170 to 200 member team, and we would like to support you. See, the market has changed. Gone are the days about 5, 7, 10 years back when we had only IC engines. Today, the ZEISS is very well known for CMMs, as you all know, coordinate measuring machines in the metrology room. Today, we have moved into batteries, electric vehicles, electronics used in consumer electronics or in electric vehicles, aerospace, space domains, medical electronics, and medical manufacturing, and large parts, and so on. So the market transformation has happened, and we are there to support the industry. Just looking at a car, you know, uh, we didn't have many of these items in the car maybe 5 to 7, 10 years back. We only had transmission and engine and probably car body. Today we have batteries, we have e-motors, we have a plethora of power electronics, fuel cell, and the thermal management systems, dashboard electronics. Things have changed quite a bit, right? So that is where we have a challenge, how to move from a mechanical engineering industry into understanding failures which are in the electronics. We have solutions as ZEISS. We have solutions in 3D metrology and inspection and failure analysis. So this is these are the products what we have, and today we'll focus on one particular product line, which will help you improve quality in PCBs, sensors, antennas, charging areas, lighting, power electronics, housings, and connectors. So everything to do with the electrical and the electronics area of a car and automotive, we will be touching upon today. Some slides to show you what will come. You can see that you have piece assembled PCBs, connectors, and there are going to be failures in most of these areas. How do we address the failures? How do we inspect these parts in a non-destructive way when it is under development, or you have a master component and you want to inspect it? So these are the questions what we will be addressing. Okay, some of the components which we have measured and which we have a lot of knowledge on is laser radars, automotive controllers, ADAS camera modules, millimeter wave radars, and the solution space is given at the bottom. I know you cannot read it, but you will get a download of this system later on. Talking about ECU, there is a lot of issues which come up in ECU, which we have faced in the market. Internal structure, after it is sealed, how is the internal structure? Is the heat dissipation structure properly glued or not? Is the sealing test failing? So, what are the reasons? Is there a porosity in the product? How is the assembly quality? These are some topics which we will address. Coming to BMS and auto electronics, there are areas where structural inspection, internal soldering, electroplating quality, terminal sizes, welding inspection, pin and needles for locking the part, whether the size is correct. All this can be addressed in our equipments. One of the most complex things which are coming up today is the lighting systems, where it is a combination of optics, electronics, rubber, and many other mechanical parts with a lot of movement. So these can be addressed, and many of the world class automotive lighting companies, they use our systems for this purpose. What is FA? Failure analysis is the systematic investigation of parts, assemblies, or systems that have malfunctioned or failed to meet specifications. Now, FA has to analyze and identify the root cause. Without, if it's the best case is to do the root cause analysis without touching the part, without opening the part, without dismantling the part. So that is something what we are going to talk today. FA has to be easy, so we use non-destructive methods like X-ray and CT scanning. Which is what me and Suresh will explain. It has to be faster so that you can implement corrective actions in a quicker way. And FA is critical for meeting the automotive quality standards. Some examples of failures which have happened without naming the companies. There has been a case of unintended acceleration in electronic throttle control systems. Cases of airbag inflation crisis between 2013 and 2019. Ignition switch defects, which can be addressed using our solutions. Backup camera failures, touchscreen failures, so on. This is just an example that how you have to get to the root of these problems. It could be software, it could be a chip failure, it could be a soldering defect, or it could be a mechanical part assembly failure. Now I will show you what should be a failure analysis lab look like. This is our imagination of how a good automotive leading players, Indian automotive on auto component industry is one of the world's largest. It comes in the top two or top three, and how a failure analysis lab should look like. This is our idea of it. You can see there are about 10 equipments. Okay. First one, number one, you see on the left is an optical system, which can attend to your surface analysis techniques, which can also do a little bit of assembly control topic. Then you have a CMM, which is listed here. Then you have an X-ray machine of different varieties, two X-ray machines. Then you have a non-contact scanner. You have an electron microscope, digital microscope, and so on. What are the topics what we address? We address material composition analysis. If you have any material topics, we can address that. Internal defect and structural inspection, surface analysis, coating topics, technical cleanliness, whether your product is clean to be supplied, NDT, that is non-destructive testing and assembly control, dimensional analysis, mechanical property analysis. So these are the topics of failure analysis what we can take up using our equipments. Today, Suresh will do a deep dive into these two topics: ZEISS Metrotome, which is an X-ray device, ZEISS Versa, which is an X-ray microscope device. These are the two equipments what we will cover today, and we will see some use cases. Where X-ray can be used is incoming inspection, process validation, root cause analysis, and qualification testing. ROI, generally, X-ray is a quite expensive device, but one failure, a single recall which is prevented, can justify 10 years of the investment of CT inspection. So if you reduce your warranty claims by 10%, that is a big saving for your company. This is the example of a headlamp, a complex headlamp inspected in a CT device. So what drives us is a passion for customer success. We want to see that Indian automotive companies and auto OEMs and startups, there are many startups which come to our quality excellence centers. We want you to be successful. And that's why we are doing this seminar to showcase our solutions to you. So this is what I wanted to say. And now I would like to hand over to Mr. Suresh Babu, product manager of ZEISS for X-ray. Suresh, will you be take it up?
Thank you, Manoj sir. Thank you, Priyakshi, for managing this session. My name is Suresh Babu. I'm the product sales manager for Calzais India. I take care of X-ray product portfolio. And today I'm going to cover about quality assurance and advanced CT inspection for EV and power electronics. The duration is roughly like 30 minutes, followed by Q&A session. This is the agenda of today's webinar. I will be explaining about like why X-ray CT is significant for NEV and electronic application, and specific application and flexible X-ray solutions. Overview about X-ray technology and a Q&A session. So why X-ray is significant for EV application, EV electronics application? In a traditional method, for example, connector component is basically it's a plastic part, but it is really a complex part having thousands and thousands of dimensions. So if you want to do a measurement or if you want to do a reverse engineering of a connector part, like you need plenty of equipments, as you can see on the screen, like optical inspection, microscopes, CMMs, optical CMMs, surface and form products like contour measurements. And you may need a lot of jigs and fixtures. You may have to do some manual measurements. Sometimes you have to do non-destructive inspection. So there are like various types of inspection you may have to use in day-to-day manufacturing, uh, in the day-to-day manufacturing methods. We have a solution. Typically, for a connector part, if you want to do reverse engineering or inspection, optical inspection could take roughly like 10 hours. CMM inspection can also be like 9 hours. Contour profile measurements can be like 2 to 3 hours. And if you want to do reverse engineering, it could take from 3 days to sometimes even 5 days, collecting all the information from different machines and then putting it together and create a CAD model. So this X-ray CT is like one-stop solution which can actually avoid all this inspection equipments. You can perform, you scan a component and you can do surface level inspection. You can do non-destructive inspection. You can do metrology. You can do like measurements and defect analysis, reverse engineering. So all the functionality can be done with one single machine at a very short timings. For example, as I explained in the connector part, if you're doing a traditional method, it may take like at least 7 days for the inspection and for the reverse engineering. In CT scan, you can actually reduce the timing from 7 days to for example, 2 days. So in like 30 minutes to like 1 hour, you can do a good scan. And then once the scan data is available, you can able to do a measurement, and you can also able to do reverse engineering. So the typical turnaround time is like less than 2 days when it comes to connector application. This is just an example. Then you can imagine about the PCB, you can imagine about sensors which goes to the modern cars. So the advantage of CT technology is that it provides a three-dimensional view. It can be used in wide range of applications like quality assurance, product development, process control, failure analysis, reverse engineering, and rapid prototyping. So it gives a three-dimensional view. With the three-dimensional view, what we can able to do is like we can do internal defect perform, identify the internal defects, measure the geometries of the component, extract the STL data, superimpose it to the CAD model. You can do wall thickness analysis and many more applications you can perform using the CT technology. So when we talk about specific application with respect to X-ray, like this X-ray and CT can be used in a wide range of application in the manufacturing industry. It could be regular IC engines, automotive like powertrain, wheel, structural suspension parts. It can also be used in aerospace, foundries. When we talk about specific to NEV, new energy vehicles, like battery trays, cooling systems, stators and rotors, suspension parts, structural parts, electronics, and so on. So when we specifically talk about automotive electronics, power electronics, like there are like different components which goes to the modern electric vehicles, like IC chips, which goes on to the PCBs, sensors. Like when we talk about sensors, like there are like wide range of sensors available in the modern cars. For example, in the powertrain or in the battery management system, there are like n number of sensors uh, to monitor the braking system. I mean the ADAS, many applications. There are about like hundreds of sensors in a normal EV car. When we talk about a high-end EV car, it could be like up to 200 sensors. So all the sensors, like it is very important to scan the sample. It could be for new product development, or it could be for reverse engineering or failure analysis. So CT scan is helps a lot to the industry to identify the root cause analysis of the defects and failures. Antenna parts, housing parts like inverter housing, uh, battery management systems, displays, infotainments, connectors, lightings, car keys, chargings, and power electronics and other power electronics components. So these are all the major applications where CT could be very useful in day-to-day life. So apart from electronic parts, the X-ray technology can also be used in applications like wheels, aluminum alloy wheels, structural parts like seat back, torque boxes, shock towers, subframe, safety critical parts like knuckles, control arms. It could be steering wheel, steering column. When we talk about powertrains, it could be IC engines or the gearboxes which goes to the EV vehicles, and then brake discs and calipers. Uh, cooling devices which goes for the batteries. So these are a like wide range of applications where X-ray could really help the manufacturer to solve the daily problems. Yeah, and I mean, like from ZEISS, we have different solutions available according to the application. So we have micro CT machines from 130 kV to 320 kV systems like Metrotome 800, Metrotome 6 count, Metrotome 800 320 kV system, Metrotome 1500. And as Mr. Manoj explained, we have this equipments, couple of equipments. For example, we have Metrotome 800 225 kV in our Pune facility, Metrotome 1500 in Delhi and Bangalore facility. So if you have any, I mean, like if you are looking for any solutions specific to electronic parts or any casting parts, please feel free to approach us. So apart from micro CT machine, we also have nano resolution CT machine, which is called X-ray microscopy, which is also available in our Bangalore facility. And this X-ray microscopy, we have wide range of product portfolio. We can achieve up to 50 nanometer resolution with this technology, and we also have like high power CT system like Volumax Titan 450 kV, which is basically used for high dense material, and also like large components having a lot of I mean like multi materials. Uh, I presented like in the previous slide, you have seen a lot of structural parts. So we have solution like 2D X-ray systems, which is called Buzzelo. So we have like outline and also inline solution in our 2D product portfolio. So when we talk about a specific application of power electronics, one of the major component is PCB. So PCB is basically the brain of the power electronics. It has a lot of components. It could be like resistors, insulators, capacitors, connectors. Like it has thousands of small features and components. It is very complex component to measure or to perform a failure analysis with a traditional method. So CT with the 2D X-ray inspection, what we can able to see is basically like it's very quick. In 2 seconds, you could able to see the image of the complete component, and you also have a facility to actually do a region of interest scan with the 2D X-ray. You can see like this is the full PCB inspection where like in 2 seconds you get one image, and then if you are if you want to do some specific region of interest imaging, this is also possible. But there is always a limitation in the 2D X-ray inspection when it comes to the resolution, and also like if you want to see perform like layer by layer analysis, or if you want to do some kind of reverse engineering, or if you want to see very small porosity on the solder joints. So it is very difficult using a 2D X-ray system. So in the 2D X-ray system, we also have different software filters with which you could able to see small features. For example, in the left corner image, you can see like without applying any filters, you can see the dark images. And then you can after applying the filters, you can see like you can see the tracks on the PCB. So this is the capability of the 2D X-ray system. The typical problem, like where the manufacturers they approaches using they approaches is basically like the solder joint porosity. They want to see the porosity, micro porosity on the solder joints. You can see on the screen on the left hand side image. You can see we could able to identify very small defects on the solder joints, and also like wire bonding defects. So volumetric sampling is possible with the CT technology. For example, you want to capture the complete volume of the defects in a particular region of interest or a complete part. So this is possible using the CT technology. And yeah, so this is a typical example where we did scanning of a full PCB, and then we could able to achieve a resolution of 40 micron. But when we do a region of interest scan, yeah, yes. So, I mean, this is basically a full part scan, and then when we do a region of interest scan, we could able to achieve up to 7 micron. So there is a significant improvement in the image quality. So with 40 micron scan on a CT machine, you really cannot able to see the defects in a very precise way. Wherein with 7 micron resolution, you can able to see very small micro porosity. So this is the capability of a CT scan system, and the software will enable the manufacturer to also do a sectional based analysis. Like volume based analysis, like transparent view is also possible with one single software. And the latest advancement in the CT technology is that ZEISS has developed AI-based automated defect detection software, which is called as ZADD, where like you can able to create the region of interest and teach the software like which defect is acceptable and not acceptable. And then once the scanning is completed, the interpretation, the reporting is automated. So you can see here like we did a program where we created a region of interest, and then uh, we teach the software like what is good and what is bad. And then once the CT scan is done, then the segmentation is automated. I mean, which saves a lot of time in the modern manufacturing technology. And apart from defect analysis, you can also do uh, dimensional metrology. You can actually measure the small features. And what is unique with ZEISS system is that, like, the machine, CT scan machine is basically built like a metrology machine. You can compare like a CMM. If you know a little bit about CMM, CMM is basically like a coordinate measuring machine having an accuracy of 2 micron. We transferred the same technology of CMM to the CT scan, and all this CT scan is having a defined accuracy. If you want to I mean, the best possible resolution is like 4 micron with a micro CT machine, and as I explained with the X-ray microscopy, it can be up to 50 nanometer resolution. So when we talk about dimensional metrology, the uncertainty can be from 5 micron to 20 micron, depending on the length of the measurement. So apart from PCB, there are like other critical applications like connectors. In the connectors, the major requirement is to do metrology. Uh, you have to really scan the part at high resolution, and with that you will be able to do the measurement. If you can see on the screen, like, we are able to measure cylindricity of a very very small connector in a precise way. So the other critical part in the modern day cars are like cameras. Uh, Cameras, basically, the fitment, the assembly of the lenses is very very critical, and also the measurement of the micro gaps, and clearance, the assembly clearance, and also like it is important to check the stress distortion inside the lens after the assembly. So these are like four critical applications when it comes to cameras. So this is all about a critical application when it comes to CT scan. And the next topic is basically the physics of X-ray. So why X-ray is widely used in non-destructive inspection method. So X-ray are the highest energy electromagnetic waves. So there are like different electromagnetic waves like radio waves, microwaves, infrared, ultraviolet rays, X-rays, and gamma rays. Like X-ray is having the shortest wavelength and the highest frequency between 10 to the power of 16 hertz to 10 to the power of 10 to the power of 16 to 10 to the power of 19 hertz. And it penetrates the material very quickly, and also like it can penetrate like plastic from low dense ferrous material to non-ferrous material very quickly. So ZEISS is having three different technologies: 2D radioscopy, computer tomography, and X-ray microscopy. So when we talk about 2D radioscopy, it's simple 2D X-ray machine where you get simple 2D projection. It is very fast. So like if you have a selected projections, and if you want to do a quick inspection, so 2D is the right method. But the limitation with the 2D X-ray radioscopy is that, like, resolution and also the data quality, and you really cannot do a 3D visualization using a 2D X-ray image. Wherein we also have computer tomography and X-ray microscopy. The major differentiator between computer tomography and X-ray microscopy is that, like, computer tomography, we have micro focus X-ray tube, which is having a focus part size of 4 micron to 7 micron, and we have a manipulator and the flat panel detector. Wherein in X-ray microscopy we have a X-ray tube and a flat panel detector. In addition to that, we have an optics. We can do a magnification of up to 40x. So we call it as like a resolution at a distance. Uh, with the micro CT machine, we can able to achieve a resolution of 4 micron, wherein in X-ray microscopy we can able to achieve a resolution of up to 50 nanometers. So this is the major differentiator between these three technology: 2D radioscopy, computer tomography, and X-ray microscopy. With the computer tomography, you can actually cover most of the applications. Like, for example, if you want to do PCB inspection, battery inspection, sensor inspection, maybe cooling system, and many applications this micro CT could able to solve. When you really want to deep dive, if you want to do a high resolution scan like in the submicron level, sample size is very small. For it could be a IC chip, or it could be a small battery sample, or it could be sensors which goes on the electric vehicles. So X-ray microscopy could able to achieve a very good high resolution data. So as I explained, the major components are the X-ray tube, the manipulator, and flat panel detector. So the major influencing factor in the CT scan is that the sample size, material density, and also the distance between the X-ray tube and the flat panel detector, and the distance between the X-ray tube and the object. So this plays a major role in to achieve the best possible resolution. In our micro CT machine, we have a distance of roughly like 1500 between the tube and detector, wherein in other 2D X-ray system it is like less than 1000 Uh, so we have wide range of applications for the industry, and I will just run a short video about our CT system, which is available in our Bangalore and Delhi and Pune facility. So this specific model is Metrodome 1500. So this specific machine is having a microfocus tube of 7 micron, and it can handle a part dimension of roughly 600 in diameter, and up to 1.5 meter in height. And we have a scanning range of roughly 600 by 800 and it's a 225 kV X-ray tube having a power of 500 watts, which is like 3000 microamperes. And flat panel detector is having a pixel size of 139 micron, and the size of the flat panel is like uh, 16 inches, which is like 430 by 430 and we have this automatic filter changer, and very recently we also added additional scatter control grid, especially for the multi-material part and high dense part. Yeah, so I think I come to an end of this presentation, and if there are any specific questions, I'm open to answer.